Hi, today we'll be looking at a MacBook Pro 15-inch from late 2012, which does not load into OS X. Now this is also with a known good target disk, a clean image of OS X. We just cannot get past the Apple logo. So these are the troubleshooting steps that we will take in this workshop, trying to get to the root cause of the issue. Okay, so the solder machine is now, the rework station is now set up. I'm going to set a predetermined profile for unleaded solder. So this will take the board right there up to about 280 degrees. That's what the temperature I need to actually get this chip off, and that comes through experience. So let's do this. Okay, the profile is now running. So it's just a waiting game now. We're up to 85 degrees, so it's going to sit there for about 20 seconds. I'm going to slowly take this board up to the right temperature. We don't need to rush it. The difference is going to be a couple of minutes from doing it fast or doing it slowly, but just with better results. Now, if you want to watch this process more intense, I know there's hundreds of videos of people reballing PlayStations, Xboxes. There is a very popular video on a MacBook Pro 2011, which, if you can find that video, shows more in depth on how we actually go do this profile. And the machine that guy uses is very, very similar to this. Right up to 175 degrees. Just make sure I've got everything else ready, because you want to act, once the chip comes off, you want to act quite quickly to take all the old solder off before the board actually cools down. It's also good to actually note the orientation of the chip as well. It's quite easy to put this chip on the wrong way around, and you have to do it all over again. Okay, the flux is bubbling away nicely. You see it being drawn into the chip. I tend to use a tacky type of flux to actually do rework rather than a liquid flux. I just find that boils away way before it's actually required. But hey, if you do this type of work, if you use a liquid flux and it works for you, carry on. I just tend to use the same Amtech flux for pretty much everything. Best way to know when the actual chip is ready to come off is to just nudge it very slightly, and when it starts actually moving, you know it is ready. So we're up to about temperature now. Still not ready. Now, the way my profile I have actually set up on this machine, if the required temperature doesn't actually take that chip off, it's going to go up by 5 degrees, 5 degrees, 5 degrees, until I know that chip, the solder has fully melted. And we're starting to melt now, so let's take this off. There we go, clean lift. Let's switch the machine off. Careful not to start the cooling cycle off, because we don't want to cool it down before we've actually got this old solder off. Now at this stage it's very, very easy to knock components off, especially when you've got components so close to the GPU. So we're going to create a little solder ball with leaded solder, and we're going to pick up the old unleaded stuff with the leaded solder. And here we go. It does take a little bit of practice. Ideally, you don't want to be touching the board at all. You don't want to be sucking any of the solder pads up, because that's when you actually trash the board. And that, trust me, is not a good feeling. If you've done this type of work, we've all trashed a couple of boards. Right. It's up to temp, nearly up to temp. Wait for it to go beep, beep. And when it does, It knows I'm ready. There we go. You don't want to be breathing that smoke in. I usually have an extractor fan running, but seem to have forgotten to turn it on this time. If you do this work a lot, you really do want to be wearing a mask. And proper extraction and filtration as well. We don't do so much rework at the moment. But I say we don't do a lot. We're still doing minimum about 5 or 6 of these jobs a week on a slow week. Can be up to 20 times a week sometimes. Acetone is a very, very good remover of flux. So that is now done. I do like to check it under a microscope to make sure I haven't actually knocked off a small resistor or a capacitor. It just makes life a lot easier when we actually do the reverse process of actually soldering the chip back on. So let's take this board off. I'm just going to quickly examine it under the microscope. Okay, so the board is now being fully prepped, it's been checked under the microscope, and I'm pretty confident this is now ready for the new chip. So we'll grease it up a little bit. When I say grease it up, we better apply a little bit of flux. Not too much flux, you don't want the chip to float, but enough for it to cover all the solder balls everywhere. Now some people I know put the flux on the actual chip. I don't tend to do that way. I just tend to put it on the board. Like I say, whatever works for you. A lot of this stuff in terms of reworking is trial and error. Everything is actually different. A little bit of, clean the chip a little bit. Okay, so let's change the profile. This time it is with leaded balls, so we are going to actually use a lower temperature on the end cycle. And let's see if we can actually focus this camera onto the screen I can see here, so you can actually see the solder balls actually dropping when this chip actually gets soldered. Okay, you can see the chip, you can see the solder ball. I don't know if you can see the pad at all. Let me see, is that actually going to focus any better? Probably not. You do need a much higher quality camera to be able to get that. Let's see if we can shine a bit more light on it. Does that help? Not much, but let's start it anyway. What we're actually waiting to do is the chip to actually drop. You can see the actual chip there, hot nozzle, heat underneath. This is called a 3-zone rework station where heat comes from the top, the bottom, and also you have infrared heaters heating the whole board up. Kind of stops it from actually warping. Ready up to 85 degrees. So this is going to go up to about 200 degrees maximum. The solder will melt about at 187. Okay, we're coming up to about 175 degrees now, so we're going to start seeing a little bit of action on that chip. You may see some flux flowing from outside underneath it. You'll see some of those solder balls starting to go shiny. And only when they've all melted will you see that chip drop. Sometimes it drops quite dramatically, and sometimes very, very slowly, where you don't even actually notice it's actually soldered and dropped down. And here we go. So we're on the last point, the last ramp up on this rework cycle, and there goes the chip. That's what we were waiting for. So I usually don't dwell too long on the last cycle. Probably about 10 seconds max, and that way you're for sure that everything has actually got soldered. And there we go. So we're going to stop it, cool it, And you still see those nice shiny solder balls go a slightly dull colour when they've actually turned from a liquidous state back to solid. Now that concludes the rework side. That actually concludes the repair side of this, but one thing we've got to do is actually test this to see it's actually going to work. Often you do these kind of stuff, spend a lot of time, a lot of your own money, and when you put it all back together, it's actually in worse shape. Then you've got to go back, do it again. Hopefully not that often. A lot of this is really, really experience driven. You can only get good at doing this by practicing. I used to have an infrared rework station before this, and that really was no good. Okay, the machine's mostly been assembled. It's been through the ultrasonic clean as well as through a reflow oven just to dry it off at a very, very low temperature. I'm going to put the final screws in, and then we'll see if this is going to fire up for us or not. SSD in. Last screw. Battery plugged in. Make sure everything else is plugged in okay. We're all good. Right, bottom case loosely on. There is a good chance we'll have to open this up, so I'm not going to screw it all back together again. I'm going to show you the failures as well as the successes. Let's see if this works. The chime is good. There we go, here's the Apple logo. Is it going to give us full access to the desktop? Let's see. So this is where it actually got stuck last time. Oh, I see an arrow, and there we go. And that is another job completed successfully. Now all there is to do now is to test it off, run some service diagnostics on it, make sure it passes the Apple video test. If that all passes okay, it's off to the customer. Thank you.